Hello, dear subscribers and guests of the channel. A star named Mystery, what we still don't know about the Sun. The Sun is incomparably closer to us than any other star. It is only 8 light minutes away, while Proxima Centauri is more than 4 light years away. It would seem that we should know everything about the Sun and even more. However, that was not the case. The Sun is a dazzling challenge in every sense to our ability to explore the world. It is being closely studied in all possible ways, from good old optical observations to the detection of solar neutrinos, and yet it still holds many secrets. An ordinary but native star. I would not like to create the impression that the Sun is a solid white spot in the scientific picture of the world. Of course, we know a lot about him. Even in a very condensed form, this knowledge, if recorded in one book, would amount to several weighty volumes. Let's try to list the most important theses. The Sun is more than 100 times larger than the Earth in diameter and 330,000 times in mass. The temperature on its surface is 5,500 degrees Celsius, and in the center it is 15 million. The Sun is about 5 billion years old. The Sun's energy source is thermonuclear reactions, which convert 600 million tons of hydrogen into helium every second. This fuel will last the star for about 5 billion more years, meaning it is now in the middle of its life. In general, the Sun is a typical star of spectral class D, average in all respects. The work of the Sun as a thermonuclear heater has been well studied, the main process to which the Sun and at the same time we owe its existence. Thermonuclear reactions are taking place in the center of the star. Photons are generated in these reactions. The pressure of this radiation literally bursts the Sun from the inside and prevents gravity from compressing it. The path of a photon to the surface photosphere takes tens of thousands of years. It is absorbed and re-emitted by matter countless times. Having reached the photosphere, light finally breaks out into the vastness of space, including in order to warm the Earth. But this is, so to speak, the main activity of the luminary. It is accompanied by a great variety of side effects, and so they are often mysterious. The question of the crown. One of the most famous mysteries of the Sun is related to the temperature of the corona. The corona is the outer thin layer of the Sun's atmosphere. It is farthest from the central heat source and, it would seem, should be relatively cool. But that was not the case. The temperature of the underlying corona layer, the chromosphere, is measured in tens of thousands of degrees. But in the thin, some hundreds of kilometers transition layer between the chromosphere and the corona, the temperature suddenly rises to millions of degrees. Why? What warms the crown? An endless crackling firework of microscopic flashes, or an electric current flowing through the plasma, or maybe waves like sound waves for sophisticated readers. Let's clarify, magnetohydrodynamic. All 3 hypotheses have very solid supporters in the scientific world. This means that no one knows for sure. Periodically, the media cover the news with a headline like "Scientists have finally solved the mystery of the high temperature of the corona." They would be more exciting if this mystery had not been revealed with enviable regularity for many decades. The wind knows. Another huge mystery in every sense is the solar wind. This is a stream of charged particles, mainly protons and electrons, constantly flowing out of the Sun. There are 2 types of solar wind, slow 300 to 400 kilometers per second and fast 700 to 800 kilometers per second. Isn't it true that even a slow wind is not so slow? The solar wind literally fills the solar system. However, it is very sparse. There are only 5 to 10 solar wind particles per cubic centimeter of near-Earth space. For comparison, there are more atoms in a glass of water than there are glasses of water in the world's oceans. What an astronomer sees as a flow of matter, an Earth physicist would rightfully call a vacuum. The main thing we don't know about the solar wind is whether we should be surprised by its existence. On the one hand, the crown is very hot, although it is unknown why. It seems natural that some of the matter escapes from it into space, like steam from a saucepan. But on the other side of the scale is the colossal gravity of the Sun. And we don't know who should win this contest. There are simply no good equations describing the flow of the solar wind, and those that are solved in both directions. In other words, they describe both the outflow of matter from a star and its fall onto a star. If astronomers ever discover the sun to point zero, it is quite possible that it will absorb the surrounding matter rather than spraying its own into space. However, the problem can be solved by adding an additional source of energy to the solar wind. That is, assuming that the substance leaves the corona not only due to evaporation, something additionally pushes it out. If only I knew what it was. What about plasma waves in the corona? Another mystery of the solar wind is its turbulence. It does not flow in calm streams like a flat river. Instead, the plasma is bubbling and almost foaming, like a mountain stream. Why? It probably has something to do with the mechanism of its expiration. It's a pity that we don't know it yet. A restless luminary? Astronomers also have questions about the sun's magnetic field. However, there is nothing surprising in the fact that the star has this field. The magnetic field is generated by electric currents, that is, the orderly movement of charges. And the sun, for the most part, does not consist of neutral atoms, but of naked protons and electrons. It is necessary to bring them into an orderly movement, and a current will be obtained. What's amazing is that the sun's magnetic poles are drifting so fast that every 11 years the north and south poles switch places. In other words, there is a 22-year cycle. The north magnetic pole returns back to the same place every 22 years. Why is this happening at all, and why is the period exactly 22 years? Of course, there are models that answer this question, but how can there be without them? But there are still a lot of unclear details in them. The famous 11-year cycle of solar activity is associated with the 22-year cycle of the pole shift. Its best indicator is spot small areas of low temperature by the standards of the sun. As long as the sun's magnetic poles are near the poles of rotation, the number of spots on our star is minimal. This is the minimum of an 11-year cycle. As the magnetic poles drift towards the equator, the number of spots increases. It reaches its maximum when the sun's magnetic poles are at its equator. This is the maximum of the 11-year cycle. After passing the equator, the magnetic poles again approach the geographical ones, only to the opposite ones, and the number of spots drops to a minimum again when the sun is spitting. Solar activity is generally full of mysteries. Of all its many manifestations, let's choose the phenomenon that has perhaps the most noticeable impact on our planet. These are coronal mass ejections, CME. CMEs are billions of tons of plasma clouds spewed out by the sun. They are denser than the background solar wind, but still very sparse by terrestrial standards. In terms of volume, such clouds significantly exceed the Earth and regularly cover it with their heads. Such bathing can cause a magnetic storm. Therefore, CMEs are interesting not only to astronomers who are far from earthly concerns, but also to practitioners. Statistics show that coronal mass ejections are closely related to flares. Strong flares are often accompanied by CMEs and, consequently, magnetic storms, which attracts public attention to them, which is not always commensurate. But what is the nature of this connection? Again, a mystery. Could the flash be causing an outburst? Or is it caused by it? Or maybe the flash and the ejection are two consequences of the same cause. As usual, all three hypotheses have supporters. It would seem that it is enough to look at what happens earlier. An outbreak or a release of a substanc status show that coronal mass ejections are closely related to flares. Strong flares are often accompanied by CMEs and, consequently, magnetic storms, which attracts public attention to them, which is not always commensurate. But what is the nature of this connection? Again, a mystery. Could the flash be causing an outburst? Or is it caused by it? Or maybe the flash and the ejection are two consequences of the same cause. As usual, all three hypotheses have supings. Follow the posts, ask questions, and share your impressions. See you among the stars. Watch my channel, like and subscribe. You will learn a lot of new and interesting things.